Hello everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it, pause the video, come back, and we will do it, maybe even hopefully offer different approaches. Okay, a circle in the XY plane has that equation. How long is the diameter of the circle? Ouch. You got to get this, the classic, just plain vanilla way to do this is to get this equation in the form x minus h squared plus y minus k squared is equal to r squared. This is the standard form of a circle, and then you can pick off the radius, and then you do 2r, and that's the answer. The answer here would be 2 times r. But you got to turn this whole equation, into this form. And then we do the word complete the square. Yes, complete the square. A little bit of a dangerous maneuver, but we will do it anyway. What do you think, Seth? Complete the square?
Okay, well, I would proceed with the algebra immediately without naming the technique called complete the square.
Well, of course, when you're taking the test, of course you're going to do that, but it's natural to say, what do I do? Oh, I have to complete the square.
No, I didn't think of completing the square.
Really?
The way I thought of it is start with what you wrote and then use whatever's necessary, including matching of coefficients, to find h, k, and r.
Right. Yeah. But in the end, it comes to, okay, so can I have the honors of completing?
And it's also, frankly, it is completing 2 squares.
Yes. Do you want to do it, or should I do it?
I want to do it.
You do it. Go ahead. Complete the square.
So
I've done enough.
What we're going to do is match.
But try to do it quickly.
This guy with what Joel wrote out. So I'm going to do is expand out what Joel wrote. X x squared minus 2hx.
Seth, why don't you do it quickly?
I am doing it. This is what I'm doing.
No, do it quickly and then explain how you do it. Because there are going to be people who are dying to see the answer. Why don't you just blast right through it and then explain how you do it? Because it's going to take a long time if you explain this and do it at the same time. Okay.
Now we match.
Okay.
Good. Now the interesting part. Minus 22x matches with minus 2hx, and therefore minus 22, or h equals 11.
This is a very clever way to do it, actually. I never even thought about this. This is a really clever way to do it. So k is going to be 15. Negative 30. No, positive 30. Positive 30. Positive 30. We have to erase that because we can't see that it's positive, right?
Yeah. Oh, it's positive 30?
Yeah.
Or positive 30.
Yeah, positive 30.
Minus 2k equals positive 30, so k is equal to negative 15.
Right, yeah.
Right?
Right.
Now, okay, so what do we do next? We have to make, let's see, and then let's move the r squared over to here. So we get minus r squared. Right. And this becomes 0. And so we want minus r squared plus k squared plus h squared should equal positive 90.
Right.
Now we just plug it in. We know h is 11. Wait, what? R squared. H, so we plug this in. So we get minus r squared. Now, okay, k is 15. K is negative 15. So we get minus 15 squared plus h is 11 plus 11 squared. Let's see. This is so. Well, I want 90 should equal. 90 should equal this.
Right.
So then I figure out what minus r squared is.
Yep.
R minus r squared. Let's say bring r squared over to the left. So I get r squared equals minus 15 squared plus 11 squared minus 90.
Right.
Right.
And then we're done.
Then you figure it out.
Yeah.
With a calculator.
Right. Yeah. It's 225. Oops. It's so unbelievably. Oh God. 225 plus 101 or 121 minus 90, and then you have a calculator. So we'll get the calculator. 225 plus 121 minus 90 is 256, which is a perfect square. It is a perfect square. R squared is 256. So R is 16. And it all works out very nicely. If that wasn't a perfect square, you would...
Wait. 16 squared is 256?
I think so. Yeah, because 15 squared is 225. Yeah, so 16 squared. 16 times 16 is 256.
So R is 16.
R is 16.
And so the diameter is equals 32.
Right. Diameter is 32. Okay. Yep. Very good. Wow, that's nice. That's a really clever way of doing it. I never even thought about doing it that way. That's really smart. Yeah. Wow. Cool. Okay. Now
it's a very powerful and it's a very powerful approach,
right,
to working with polynomials.
Right.
Unfortunately, it's not emphasized, and in fact, some professors in combinatorics said that their students in college, their students in their math classes in college, didn't use this approach.
Yeah. Matching coefficients is used in usually problems that are more obvious that how you would match coefficients, but not this one.
Yeah. Well,
the clever one is
completing the square is a special case of matching coefficients.
Right. That's the thing is what you did, which was really clever, is you multiplied this out first, and then you matched the coefficients. Yeah. So I'm dying.
How else could you do it?
Well, I'm dying to show you.
Completing the square, right? Completing the square. Yeah.
Right. So I'm going to erase all of Seth's beautiful work, and I'm going to do it the more quote-unquote traditional way. Because I'm going to do it, I'm going to blast right through it, so it's going to be faster. I'm not sure whether your way would have been faster as opposed to the quote-unquote the more traditional way of doing it. That's mostly taught in school. But you want this form to be this. So you take half of 22. So you go x minus 11 squared equals, but because of this, you have to add a 121 to this side. Because this is x squared minus 22x plus 121 plus 11 squared. So you add a 121 to that side. Then you do the same thing here, y minus 15, or y plus 15. It really doesn't even matter because you're squaring it anyway. So you add a 225 to this side. And then you subtract the 90 over here. because you move the 90 over. So this is equal to r squared. And we have the same equation that Seth got. So as you can see, this is done a little bit faster. And there's fewer calculations, actually, if you do it this way. There's less writing. There's much less writing than if you do it this way compared to what you did. Because you actually have to expand this out. And you can make mistakes, and then you have to solve for this. Yeah, you're right. Yeah. This is much faster.
So the approach, again, so it's helpful to know that it's a good idea to apply completing the square technique. And so the technique in completing the square, let's write it out. If you have x squared plus ax, to complete that, what you do is you write it as x plus a over 2.
Right, a over 2 squared. And then you have to add a squared over 4 to the other side.
Squared. And then this is equal to that minus what the extra thing that you put in, which is a squared over 4.
Right, exactly.
So it's easier if what you could do here is write this is x squared plus 2ax. But because, of course, use a different symbol, bx equals x plus b squared minus
b squared. B squared, right. Yeah, okay, basically, cool. You cut this coefficient. You cut this coefficient in half, and then you add the square of that coefficient cut in half to the other side to balance it. Because you bring in a collateral damage when you expand x minus 11 squared.
Yeah.
You know, it's x squared minus 11x minus 11x plus 11 squared. So you have to this is collateral damage sort of, and you have to add it to the other side. Yeah. I mean, some places, you can also, but it's more work. It's more work is to think about it this way, but it's extra writing, and who needs it? Is you complete the square x minus 11 squared, and immediately you subtract a 121. That's what Seth did, right? And then you do x minus 15 squared, and you immediately subtract 225. And then you have the plus 90, and then you have the 0, and then you take these three things and move them over. Come on. These three things. Where are they? Where'd they go? Oh, these three things. This one, and this one. You move them over. It's all the same thing. So, okay. So let's see how they did it. So I
think okay, we have two approaches. One is this principle of equating coefficients.
Yeah, which is really powerful.
One principle.
Really powerful.
Second is this routine.
Right.
Or this rule for completing the square is efficient. So it's a good idea to learn it.
Yes, for the SAT. Right now, we're not into learning. We only learn the theory to help us do the problem in as short as time as possible. So Seth's approach is much more general. Seth's approach can probably be used for more complicated problems. Seth's approach is brilliant and great.
But you have cubes. You could do it with cubes.
Yeah, it's a fantastic approach. But this is the quick and dirty method of getting the answer as fast as possible. So, good. Okay, great. So here we certainly have a difference between a really cool, sophisticated method that's powerful versus just getting it done as quickly as possible. So we all agree the answer is 32.
So again, the approach is with a recipe that you could learn and memorize.
Right. Yeah.
Complete the square. You could solve problems like this more efficiently.
Right.
Yeah.
Yeah.
And
so
if
that's
used
for the SAT. Yeah. Okay. So it'll be interesting to see which way they did it. Did they do the minus thing? You know what they also may have done is, let's sort of predict, they may be doing this, they may bring this thing in. Oops, sorry about that. They also may bring in this thing about x squared plus 2x plus, x squared plus 2ab. I don't know. You'll see. They may bring something else, and we'll see. Okay, let's look and see how they do it. 32, and there are no units. Always have to check units here. There are no units in this problem. Okay, so how did they do it? 4 steps, so they didn't spend that much time doing it. Okay, since we know the diameter, it would be helpful to rearrange the equation in standard form. There we go. Oh, I see. Wow, they should have did it like the way you did it. Wait. Oh no, now we need
Oh,
to complete the square. Let's take the coefficient of the x term, have it, and square it. Right, they use the formula side. You add it to both sides. Okay, so they added
yeah.
it to both sides. Yeah. So they use the formula method. Yeah.
So this halving, this technique, halving and squaring is completing the square.
Right. That's the recipe for completing the square. And they did exactly the first approach I did, where you take it and you add it.
Yeah,
You add it to the other side. Yeah.
yeah.
So I'm gonna do with blue. Yeah, they added it to they added it to the side, right? And then you just do it, right?
Right.
Yeah. Yep. 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 Yeah. You know what's interesting? If you have a calculator, I wonder whether the calculator may be powerful enough, but it would be a complete waste of time if you had a graphing calculator. It may be powerful enough to type this in to the equation, and then have a graph, and you would see a circle, and then you could pick off the radius. That would be really stupid. But
Yeah, you could do that.
yeah,
Yeah,
you could
yeah.
do that. You could do that but the amount of time it would take you to type this into the graphing calculator accurately, and the amount of time it would take you to figure out how many units the diameter or the radius is not worth doing. Okay, great. So, I guess that's it. So, we are Brothers Chaiken. I'm Joel. I have a PhD in mechanical engineering from Columbia University, and Seth is a PhD in math from MIT. He's a professor emeritus at SUNY Albany. He's been teaching there many years, now retired from the computer science department. We're here to hopefully offer different approaches on how to do the problems. Today we were successful in that we offered three approaches on how to do the problem. And some approaches are better than others. Well, some approaches are really much better than others if you're taking a time test. In terms of studying for the test, we advocate going to Khan Academy. They offer 2 online classes with hundreds, like 600-700 math questions you can practice on. Probably same for English. Do those. They partner with the SAT people, because now after 2016, the SAT is more of a test of what you learn in school rather than anything else, really, at least on the math side. So and they partner, so they basically tell you what are the topics on the SAT. This is going to be on the SAT. Do these practice questions, and then of course go to the College Board and download as many of their actual old tests they offer and practice on those as well, and then you'll be all ready for the math SAT. So please dislike, please give us comments on our videos. We really like the feedback, and if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. That's it. A mouthful when we end. I guess that's it, right?
That's it. Yeah.
Great. Okay,
That's it.
everyone. Have a great day.